finally learned how to get rid of this thing. All right, so my name's Eric Hunter Petros. I'm a remote instructor for a couple of organizations. I also here at Code the Dream as your Python Essentials code mentor for the Lizard cohort. And so on this pre-holiday evening, we're going to go over some of the learning objectives in a little fun exercise. So everybody just kind of sit back and let me drive. And if you have any questions, come off of mute. We will just build a program. We're going to make a little 2D game from start to finish. So we're going to go over all the basic fundamentals that you've covered so far. We're going to have some variables. We're going to have some data types. That's going to do the game state, like the position, the health, the score. We're going to do some functions for reusable game logic, like collision detection. That's going to be important. We're going to do a little bit of classes. I know you guys haven't really covered that yet, but they're not as complicated as you think they are. It's just a little bit of object-oriented programming. So we're gonna have a couple game objects. We're gonna do a tank, we're gonna do a bullet, we're gonna do an enemy. We're gonna have some loops, which is the game loop pattern, kind of the heartbeat of the game. We're gonna have some conditionals, like did that bullet hit? Collision detection, did it hit a wall? Is it at the end of the screen? Game state checks, is the game over? And then lists, how to track multiple bullets, multiple enemies. And then my most important thing is documentation. It doesn't matter how good of a coder you are, you could be the best coder in the world. But if you don't get your documentation down, your team and your future self is never going to know what that beautiful function was. Like you can make the most wonderful function, elegant, best time and space constraints that you could ever think of, and come back to it 6 months later and not be able to explain to what it is or what it does because you didn't document it. So to me, documentation makes the coder. So with that, I put together a little file. I shared the repo with you guys. If you have any trouble getting it, just reach out to me. Really, the only thing you're going to need to pip install is pygame and maybe NumPy to get this running in your virtual environment. If you have any trouble setting up your virtual environment, just let me know. I believe I already started this one up. So generally, what you would do is you would pip install whatever dependencies it is you need. In this case, it's pip install the requirements, which is this text file right here. So that command will literally just come in and install all of these. This is a little bit different from what you're used to in like JavaScript. The requirements text is an easy way to package in the dependencies for whatever program you built. And then
It
in the
sounds
docs,
like that would be
go ahead.
the equivalent to npm install, right?
Basically, yeah, it's
Okay.
it's very
Okay.
similar
Cool.
to an
Cool.
npm install. Yeah, so docs, assets, your basic structure. So yeah, you can see right here in the virtual environment, my libraries. So this is what the pip install installed. So all your packaging, your NumPy, your PyTokens. So these are all the different Python libraries that will make this game do what it does. They're going to be in your virtual environment. And you install them all with just this. Welcome, Rebecca. Let me add you to the roster real quick. I'm just doing a basic intro right now, so just get settled in. Let me know if you have any questions. Come off mute if you do, right here. Let's see. Rebecca Kim. All right. So yeah, the development and testing tools are really not going to need like the Flake 8, that's linting, same with the code formatter. So these are ones that you can just ignore. We're not doing multiplayer right now, so you don't have to worry about WebSockets or the AI HTTP. Like those like overwhelm you. But like I said, the repo is available in the Slack, so feel free to download it, fork it, zip it, whatever you're comfortable with, and play with it, break it, come back, ask me questions, and we'll go from there. So what we're going to do in the lesson plan is we're going to go step by step incrementally. And in doing that, I'm going to start with my first file, which for brevity's sake, I'm just going to name it main.py because that's what we're going to be coding in. And in main.py, I'm going to start with my documentation because since I have my helpers in here, documentation is going to help my helper as well. As you can see already, he's jumping ahead of me. My little eager puppy over here wants to import pygame, import random, import math, right? But for right now, let's just go over what's going on here. All right. So we're going to demonstrate the Python fundamentals through simple game development, Thanksgiving tree, right? We're going to cover variables, functions, classes, loops, conditionals, lists, and then type ins, which is self-documenting code, which is what we're doing right here. We're going to do some very simple controls, WASD or the arrow keys to move the tank around, space bar to fire a bullet, and the R button to restart the game. Just real simple logic right now so that you guys can just get the concepts and then you can build upon it later. So the biggest thing I would say whenever jumping into something is just get it working first, make it pretty later. Like my first couple of programs were spaghetti code all over the place. And then afterwards went back, got them working, looking nice, refactored. So first we're going to start with the imports, right? So we import the libraries at the top. This is like in you're going to hear me say a lot of restaurant terms because I was in the restaurant for 20 years. I started uh, cooking up code basically. So your libraries is like gathering your ingredients before cooking. Each library is going to serve a specific purpose. All right. So we're going to first import pygame. If I could type today. And so from import pygame, we're going to have all of that stuff that I don't want to put in yet. But pygame is the game engine for the graphics, the sound, and the input. So all of this is built into this library, and now it has been imported into our Python files. So rather than having to write all of the code and all of that stuff for like gaming physics and sound and keystrokes and event listeners and all of that stuff that is really high level for us right now, Python makes things really easy by having that all bundled in a nice library that somebody spent countless hours building. And now that I can just import. And so next, import random. We're going to import the random for randomness of the enemy behavior, making them move around on the map so that they zig when they zig and they zag when they zag. You know, random is very important for a lot of things. Like say you need a random dice generator, or you need a random seed for training your AI machine language stuff that you're going to be getting into later in this semester. Math, which we covered last week, is going to cover a lot of your libraries. So if you need to get the square root of something, or God forbid you need my favorite, the Fibonacci sequence or something, rather than having to understand what that is, you can import math, and math has that library in a method. An interesting thing to point in right here, I only have this part, the from typing, import, list, tuple, and optional as a backwards capability, because anything over Python, I believe 3.9, this is already built into the core Python. But because you don't know what your users are using, like maybe somebody's working with a 3.8 or something, and you want them to still be able to run this code, this little line right here will provide backwards capability for me, even though I've run it 3.13 something. Oh, 3.137. There it is. There. All right. So the first thing we're going to do is we're going to initialize pygame. And you can see
I
that,
have
right?
a question.
Go
In
ahead,
the
Mira.
from typing import optional, meaning it can be any other types, right? Optional here.
Exactly. Yeah. And actually, this is just kind of redundant, really, because now that you have list and tuple in here already, you don't really need optional because you, if I remember right, Miriam, you're running at least like 3.13, right?
Yes.
Yeah. So yeah, like I said, these are just redundant for backwards capability for you, but optional as of 3.10, I think, has just completely fallen off. It's all included. So like if you were doing like a dictionary and then bracket list, that would already be in there. Okay. All right. So now we're going to wake the game up, right? By initializing pygame. This is the first line of code after the imports that the game is going to see. So this is like preheating your oven. You're letting it know we're going to be doing some stuff. And so a lot of you guys might be familiar with working with like iframes or working with Canvas or maybe even tkinter as a GUI or an interface of some sort. So what we're doing is we're going to give the constraints to Pygame right here once we initialize it. We have our screen width. And since I have a little bit bigger screen, let's go ahead and adjust this. We're going to do, let's get crazy. We'll get 12, what is it? 1280 is the standard, 1280 by 1160. See what that says. Might get a little mad at me. Just see why it's red. But so you get your little you gain window width in pixels, you gain window height in pixels, right? The tank is going to be this size. And then you can see in here we can add more parameters if we wanted to, the bullet speed, the enemy speed, the tank speed. We're not going to add those right now because I don't want to overwhelm you with parameters yet. But you get the idea that you can continue on. And if you're curious as to why my little helper is being so helpful, when you're in your extensions, there is a Python extension that will give you a lot of your IntelliSense and your debugging and your linting to help you out a little bit. And if I remember right, I also have Pygame installed too. Oh no, I did take it off, but there is a snippets in here to make it a little easier if you really, really want to dive into the Pygame rabbit hole. I found this was really, really helpful when I was making an asteroids game, but I digress. All right, so obstacle size, enemy size. Now, frames per second is kind of important because it's not as bad now, but generally, to make sure you have compatibility, I would recommend running at a 30 frames per second because you don't know what kind of machine you're running on. Like someone generally can run 60 frames per second, but for a game this simple, it may not matter. Like we'll leave it, and if we have to come back and debug it, like we'll know right here. So we'll leave us a little note here, right? So may need adjustment for lower machines. All right, so then we're going to define our colors. Right now, we're going to keep it real simple with just white, black, red, green, blue, and gray. So the fun part, we've set our variable with the screen, right? And you'll notice from last week's lesson, we do have our colors are tuples, right? So we have the tuple and then the integer. So you have your key value pair, right? So the color and then these three numbers as a pair, the computer knows is white. This color, which is the key, these three assigned to black. Does that make sense for everybody? Key value pair. So I know last week we were kind of wondering like how many values can you have? See, Miriam's giving me a thumbs up. I think we covered that question. Finally, huh, Miriam? All right. I get to it. I get to it eventually. All right, so screen. So we're calling our Pygame. we're calling our display. We're setting the mode with the values that we set up there, the screen width and the screen height. We're also going to set the caption. That's just what it's going to say in the little window at the top. You know, like every GUI usually has some kind of a caption or something. The clock, we want to make sure we know what the game's running or if the game stopped. So we're going to need a clock function. So the clock is built in with pygame time clock method. Now we're going to get to our first class. So we might not have covered classes yet, so I'm going to give you a little broad overview of this. So classes are blueprints for objects. And since we are creating everything in object-oriented programming, almost everything you encounter can be considered an object. So in this instance, we have the object tank. Now we know there are going to be many tanks in this game. There's going to be our tank, there's going to be other players, eventually there's going to be bad guys, but they're all going to be tanks or some kind of child of the tank. Maybe we'll make a super tank or a flying tank. But whatever it is going to be based off of the original class of tank. And so this is a fundamental thing of object-oriented programming. So you can think of the class like a cookie cutter. Go ahead, Stephen.
Is it missing self dot y equals y?
It probably is because my little helper in here is getting ahead of itself. Because the class is not finished at all on
Oh,
this one.
I,
Yeah.
my bad.
No, you're good. It's a good catch. Because yeah, we are definitely missing a lot of code here, as you can see. Boom. There is your self dot y equals y. So as you can see, even though you're a JavaScript programmer, the self works very, very similar. So it's syntactically almost the same. So what we're going to do here is we're going to go ahead and fill in some of this for brevity. So now we're going to have the different things. So this is the player controlled tank, right? So self, angle, speed, health, score, bullets. This is where the optional that Miriam was asking about is being replaced because now that we have list and we give it the bullet right here, we don't have to have optional or anything like that to define it. And it's going to start empty because they haven't fired any yet. But this will help us track how many bullets are fired, right? So I hit the space bar 6 times, there's going to be bullet, comma, bullet, comma, bullet, comma, bullet, comma, until they resolve themselves. Then you got your last shot, your shot delay, because you don't want them running into each other. And then we're going to get into the functions, or do we call them methods in Python? Well, anyway. And since my little helper doesn't want to be as verbose as me, I'm going to take my code and we're going to replace this to make sure you guys can see what I'm talking about. So with the move forward, and these are called doc types. If you guys aren't familiar with this type of commenting yet, it's what you do when you have multiple lines, and generally doc types are used for defining the function within a Python function. So you'll start with the function, and then you'll put your doc type in explaining what it does, and then you put your code so that somebody can follow along with it. So this function is move forward. It's going to move the tank forward in the direction it's facing. It's going to use trigonometry, which is why we have math.cosine and math.sine. I personally don't know trigonometry, but thanks to Python, I don't have to. So it tells me we're using trigonometry to move this thing around. I'm just gonna believe it. What I do know is every time self plus math cosine the speed this direction, it's going to go that direction. If we do it the other direction, it's going to back up. Right? With self dot keep on screen, this is a function that we're going to add in a little bit that is going to do the collisions that we were talking about earlier to make sure that the tank can't go off the screen. All right.
Hey, Eric, what's looks like a fail safe at the edge of the definitions of the arrow to none. What's that mean?
Okay, so this represents the return type of methods that do not return a value in the code base.
Okay.
Yeah. So it's not the same as like an arrow function is like what you're thinking in JavaScript. Like
Okay.
this is more like if none, keep going so that it doesn't fail.
Gotcha. Skip this basically, right?
Yeah, just keep on trucking down to the next one. Because if nobody's hitting any backward right now, you don't really need the move backward function. So it knows to just go on to the next one. Is this one being used? No? Is this one? Okay. And it'll make your program a little bit faster in like, I don't know, microseconds or something. But
It almost sounds like a their version of a switch statement, right? Like you're just checking through this to see if it's being used or not. So
it's kind of, I mean, I would think of it more as like a conditional, like, is this function being used right now? If not, move on to the next one.
gotcha.
Yeah. And then, so move backward, move forward, same math, right? More trigonometry. So are you doing math dot cosine, math dot radians, self dot angle, self dot speed? Again, we have our little safety net right here to keep it on the screen. Rotate left, rotate right. Now we have the bullet. You see, we define the bullet as a string so that when we go back up here and we have our list, every time the list adds a new object in there, it's going to be a bullet object. I see the light just dinged on in Stefan's eyes. So you can have multiple bullets in this empty list right here, and you can append them and you can remove them as they are used in the game and continue moving. All right, so now we have cannon length. Going to be floating a little bit more of this trigonometry here to make sure the cannon looks right on the little tank. Return the bullet where it starts, where its direction is going. And then let's see, keep on screen looks like it cut off. So let's add the rest of my code here. Oh no, we're good. All right. So yeah, so keep on screen is going to keep the tank within the window bounds, right? So this is a private helper method. You guys probably haven't come across this yet. The only reason it's a private one is because it's an underscore. So basically all that means, and I left a little note here for you, is it's just a convention meaning that this is for internal use only. Like keep on screen is only going to run inside the scope of the tank class.
So it's a helper function you made, basically?
Right.
Okay.
Yeah. And all of this, as you can see, is going to fit inside the class tank if I end it
There's a
correctly.
second function is like outside of class. Or like it has to be maybe indented wrongly, the second function.
Yeah, you're correct. Good eye. Yeah. That's what happens when you copy and paste code, by the way. I don't recommend it. In
It's your
fact,
helper's fault. Your helper's fault.
let's see. In fact, let's make sure. So, like I said, in a couple of classes, one of the only things that I like to use this for is just to make sure you can get out of my way. That main.py. Insert proper indentation of main dot py for best Pythonic principles. And we'll let that do that while we move on. All right, so good catch, man. Methods in, they're not properly indented. Yeah. So we'll have him fix that. While he's fixing that, we're going to go into the next class. In the next class, we have the tank. So obviously, we're going to have the class of the bullet, which is going to be the bullet fired by the tank. Bullets are going to travel in a straight line at a constant speed until they hit something or leave the screen. So that right there tells you this little helper function, keep on screen, is probably not going to be part of this class. All right, so let's copy this. Let's see if it'll let me just bring it all in here. And you're not, because I got too many things going on here. All right, so now we got the indentation fixed. Get him out of our way. Get that out of our way. And see if enter. Please go away, window. All right. There we go. Again, documentation is key. So with the class of bullets, we're going to again have a set of functions inside the class that is going to define how the bullet behaves. There could be many bullets, or there could be one bullet, but all bullets are going to inherit all of this. So they're going to have these attributes. They're going to have the X and the Y for the current position on the screen. The angle is going to be the direction of the travel in degrees, which is part of why we imported the math for the trigonometry. Same with the speed, how fast it moves. And then we're going to need a radius for the size of the bullet for collision detection. So we also have the color in here. It's going to be one of the tuples that we set up here, probably white to make it easy to see. Nice little white bullets. All right. And then we're going to initialize the bullet every time it's fired. So we create a bullet at the position, traveling in direction of the aim. We're going to have the arguments. X is the starting X position. Y is the starting Y position. Angle is the direction of the travel in degrees. And with those, we're going to be able to add speed, which is going to basically stimulate velocity and make it look like the video game shot the bullet. When really all it is we just have this pixel moving across the screen. A little CG magic.
To your setting of what is it? The 60 frames per second, right?
Mm-hmm.
Now, does a frame relate to pixel count in any way? Like how it moves 10 pixels, is that going to be in one of those frames, or is that a certain amount of frames per animation? Did I say that right?
Yeah. I don't believe that those two correlate, because I think frames per second is more about your refresh rate for like your monitor and your hardware acceleration.
Okay.
So it's how the image is refreshed on the monitor.
Not how it travels.
Yeah. Yeah,
Thank you.
because that the pixels will still be the same pixel size regardless. That's why we did the screen size of the 16, 80, 11, 20, whatever up there. All right, so then every bullet's going to have the same cells with the speed, the radius, and the color. Oh, I guess we're making them yellow. I got outvoted off the island. We're doing yellow bullets. I guess those will be easier to see. So then we're going to have the update function. It's going to move the bullet forward each frame. It's going to be called once per game loop iteration, which is why we put the clock in place to advance the bullet. It's going to use the trigonometry of cosine and sine and the radians to set the speed and the angle. And that's going to simulate the bullet moving forward. So basically what's going to happen in like milliseconds is it's just going to redraw the picture and the bullet is going to move X amount of pixels over, X amount of pixels over. And the computer is going to do this a million times per second faster than the human eye can comprehend it. It's going to make it look like the game is moving. All right, so this time we have is off screen instead of is on screen. So check if the bullet has left the play area. If this returns true, the bullet is outside the window bounds and it's going to get rid of the bullet and not worry about it anymore. Remove it from the list. So the simple way of setting that is if X is greater than 0 or less than the window width or greater than 0 or less than the window height, it is going to return false. Right? Does that sound right to everyone?
That's always checking with the same rate the bullet's traveling, correct? Every time the bullet travels, it checks that.
Yep.
Okay.
So if it returns true, then it knows that the bullet is outside of these bounds. And that bullet will be removed from the game logic.
Okay, that's how you're removing it. Gotcha.
All right, so I'm going to need another class. I see my helper's getting ahead of me over there. It wants to just start the game. We're not ready to start the game yet. So Claude can relax. The next thing we're going to build is the obstacles. This will be a pretty simple one because they're going to be static. They're not going to be moving. So with the class of obstacles, it's going to be a wall or barrier that blocks movement and bullets. Obstacles are simple rectangles that don't move. They provide the cover and make the game more strategic. The attributes is we're going to have the rectangle, which pygame rectangle object, which is a preloaded thing in the library, is going to store the position and the dimensions of the rectangle wall. Color is going to be the tuple for the obstacle color. Again, we're going to initialize it with its stealths. We're going to create the obstacle with a position and dimensions. We're going to have the left edge, the top edge, the width, and the height. Everything you need for a rectangle. The rectangle is a convenient class for this instance. Like later, if you want to play around, there is all kinds of them. You can use triangles, you can do circles, you can polyhedrons, whatever your little geometry wizards want to go on and do. But for the simple class that we're doing right now for time constraint, we're just going to do some rectangles. So this is where we're going to draw the rectangles. So every rectangle is going to get inherited from pygame.rectangle. And every one of them is going to have these parameters, the X, the Y, the width, the height. So it can create multiple instances of these over and over and over because it always knows what it is, always knows what the color is. The color is always going to be gray with the tuple that we defined up in the beginning. And then we're going to draw it. So we're going to take the self, which we defined up here. We're going to take the surface, which is the game screen that we defined. And we're going to draw the obstacle, and it's going to put it in there. Pretty simple. Any questions so far? All right, looks good. All right, now we've got a tank, we've got bullets, we've got walls. We don't have anything for the tank to interact with, though. So let's make some enemies. So for this class, we're going to do, spoiler alert, row here, the enemy class. And we are missing the C on the class. Let's see what else we can copy and paste. As enemy is lowercase. There we go. Little syntax thing there. All right, so we're gonna have an enemy tank with simple AI behavior. Right now, it's just mostly going to be just randomized directions. Later, this will leave it open if you want to give it more logic and make your guys incrementally more cunning and tough if you play around. So the end right now, though, the enemies are going to patrol the arena in random directions. It could be destroyed by the player's bullets. It will hurt the player on contact. So in order to make them do that, we're going to give it the attributes: X, Y for the position, size, which is going to give it a radius for collision detection and drawing, the color for the enemy colors, the speed, the direction, and a move timer. The move timer with the random, the math.random that we brought in, is going to simulate the AI for now. It's just going to tell it for so many milliseconds or whatever, go this direction, and then randomly another direction, randomly another direction. Fire, things like that. So AI is kind of a misnomer on this right now because we're not really going to give it any AI logic in this class. So initialize, we're going to create the enemy at the starting position. Every enemy is going to have a color, speed, a size, and a starting position. This is where the random choice comes in. So self-direction, it's going to be an integer with a random choice. In here, this is how the random generates for the directions. It's going to go to a 0, 90, a 180, or a 270. So that's how you get the little guy turning around, randomly moving, turning, randomly moving. Pretty simple. Self-move timer is going to start at 0, right? The timer counts frames until we pick a new direction. We have another update function. So the update function is going to give it a patrol AI, basically. The behaviors
I
is
have a question.
go,
Sorry to
go
interrupt you.
ahead, Meryl. No.
And then 255 line and the self-direction integer random choice. So what is the type of that inside? It's the set and then a tuple. What was this? It's the color, right? What's that number?
Oh, this right here?
Yeah.
Okay, so this is going to be changing randomly from this list.
Yeah, right. Oh, it's the list, right? And then
Mhm.
the outer brackets is the another typo. Oh,
No,
it's a
this,
choice. Got it.
yeah,
Got it.
yeah.
Yes.
So the choice method, basically, we're giving it
Yes.
4 direction choices because we don't want it zigging all crazy right now. So it can either go 0 degree, 90 degree, 180, or 270. Very limited right
Got it.
now.
I see.
Does that make sense for you, ma'am?
Yes. Yes. Now it makes.
Okay. Yeah. So it's gonna randomly choose one of these and then go in that direction. And so right here is the direction, which Miriam just pointed out is the random choice method, and it's going to have one of 4 directions. The timer is going to do a random integer of every 1 to 2 seconds. And then the direction is going to use trigonometry to send it. We're going to have collision detection to have it bounce off the walls or the edges of the window because we don't want them driving off the screen. And then we're going to draw the tank. So with pygame.draw, in this case, we're doing circles. I've never seen a circle tank. So let's just do squares. See if that gets angry at me for changing all that. It may, may not. We'll give it a rectangle then. Forget what the shorthand for squares. Might just be square. But we know rectangle, so we'll do rectangle. If you want to know the different ones, the dev docs, like I showed you guys, you can just do pygame.draw and it'll give you the shorthand for, say you want an octagon or whatever. It might be OCTG or I forget what the shorthands are. But We can define that later. We are getting close to time. We'll probably run a little bit over. If you guys want to drop, I do have your names for attendance, so stay as late as you want to. All right, so the helper functions. This is where we're going to put the functions that perform specific tasks. These are going to keep our main loop clean and make the code reusable. All right, so first thing we're going to do is we're going to do the collision. And I see that all my methods are talking about circles. So just to make sure we don't break anything right now, let's just circle for some weird reason. We're gonna have circle text. All right, so let's drop in our little helper functions. And I'll just go over these briefly. These are mostly just to keep the loop clean and make the code reusable. Let's see if there's any copies correctly. All right, so we got the circle collision to see if two circles are overlapping. We've got distance between the centers, returns if the circles overlap, false or otherwise, right? Circle react collision if it overlaps with a rectangle. So we want to know if it hits the walls. Fun fact, the window border, I believe, will also count as the walls. And then we have the draw text where it's going to draw on the screen, clean up after itself. Now we get to the fun part. We're going to do the main function. This is going to be what makes everything fun. And it's a long function. So don't feel like you have to absorb it all right now. But I just want to make sure we have it all in there so we have some time for questions. All right, so let me bring it back up in here. So when this is called, it's going to start the game. And in the game main function, we're going to have a game loop, right? It's going to run continuously, 60 times per second in this case, and it does three things. Go ahead, Miriam. Oh, clapping. I thought you had a hand up. All right, we're going to process input. What did the player do? We're going to update the state. We're going to move things, check collisions, update the game logic. And then we're going to render. It's going to draw everything to the screen. That's it. That is all it does to take this game to run. Just these three things. This pattern is sometimes called the game loop or the main loop. It is used in virtually every video game. So we have the game state variables running. It's going to be a Boolean. If true, the game runs. False, it exits game. Game over. False, game keeps running. If it's true, the player lost. Score is going to be an integer. Points earned, right? And we're going to create the game objects. We have the player, which is going to be the tank class that we made. It's going to have bullets. It's going to have enemies. It's going to have obstacles. All of these classes we already made, so they're reusable. Then we're going to spawn the enemies randomly by 4 in range. We're going to start with 3, no more than 3 at a time right now. We're going to create the obstacle layout. Make sure that there are some obstacles on the screen. Not too many, not too few, but a few. We're going to run the game loop. So in the game loop, while running equals false, the game is going to keep playing. So in here, this is where I put in the key down, key space, space bar, R for reset. And you can see that they are right here, key up, key down, key left, key right, or W, S, A, and D. And simple if statements. If key or key is pressed, call player move forward.
You
If
defined all this earlier, right? That was that other math, the colors and the sign stuff.
right,
Okay.
yep. Same with the bullets. Bullets are defined. So now we're going to do a little for loop. For every bullet in bullets, you're going to update the bullet list, add another bullet to it. Same with enemies. For every enemy in enemies list, add another enemy. Same with the remove. Track what needs to be removed. Remove the bullets from the list. Remove the enemies from the list. So this game in its core concept is just a couple of lists. We have a couple of objects. We have a couple lists of objects. And then we have some functions and some for loops that are keeping track of how those things are interacting with each other on the screen. And that's it. Just the same basic stuff you guys have been covering over the last couple of weeks. Just if and else statements, for loops, and lists. So in here we have the for to remove it. Same with the enemies, obstacles, player enemy collection. So each one of these is going to be just dealing with a different instance, but it's the same simple logic: a for and an if, over and over and over. Bullets, B for B in bullets, if not any. Check, circle, react, collision. So we know the collision is if it runs into that object or an obstacle or an enemy, or if it goes off the screen, then this is going to evaluate out. And then you know you need to remove the bullet. Same with the enemy. If length of enemies in the list equals 0, the player won because there's no more enemies to shoot. All right. Or in range of 3, we put a cap on it. We're going to start with 3 enemies. So in here is where we're going to get with the rendering. You know, we're going to screen dot fill. We're going to make it black. Then we put the obstacles in. When the bullets get created, it's going to draw the bullets. The enemies get created, it's going to draw the enemies. Same with the player. Here's the little hints on the screen for the score, how to drive, how to shoot. If the game's over, display the final score and tell them how to restart the game. That's it. The clock is going to tick the frames per second. Pygame is going to display, and it's do a clean shutdown when the game is over. The last part, which is important, is the program entry point, right? This is a Python convention, so it's not something you see in other stuff like JavaScript or whatever. You're not gonna see this. So if name is set to main when you import it, which I did by main.py, it knows to reuse that file to run, right? If I wanted it to be something else, you know, pygame, tank, blah, 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 you would define in here where to find this. All this little if statement right here does is just explain to it, this is the main game function. So when you run the file, please do this. So that's it. We've built the game. We have installed the requirements because we had the virtual environment up here. So now we can try it out. And we have an invalid syntax. So this is where our AI tools come in handy. So rather than go find wherever this is, which turns out to just be in line 1, so we started right out the box with an error. Just going to give the error to the helper. Oh, because we're in a PowerShell. So we're going to turn the PowerShell off. Run this in a regular terminal.
That's what you get for using Windows.
Yeah, I like my Windows. All right, so we can ignore that guy. All right. Now, the reason why we don't see it is we have some kind of a fail. Because if you see in this one, when we run, there it is. So a little bit of debugging, show you where it's failing. So I saw the screen flicker. I don't know if anybody else caught that. So it's initializing, but it's failing somewhere in its pot. There we go. There's our yellow bullets. There's our screen. There's our score. There's our next game. Test our logic. Can I run through a wall? You can. So our collision isn't working. What happens if we run into a tank? We die. And then there's our other game fired up. So it looks like it was having an issue with the window size. And that's why it delayed in starting. So these are just little debugging things that you can see that you can go back. Now you see that there's no collision on the player, right? The only collision detection is on the enemy because the enemies are detecting the walls, they're detecting the player, they're detecting the bullets, but we're missing the logic on the player tank. You're on mute.
Your wall stopped your bullet.
Mm-hmm. Yeah, because the bullet has the collision, the player circle does not.
Oh,
See,
did we forget it or is it broken?
we probably forgot it because this
Oh.
is what happens when you let your little helper autofill for you. But
He
because of
wrote
the
700 lines of code in like 45 minutes for us. So,
yeah, so a little bit of grace. I just
yeah.
wanted something fun, so my my biggest fan Miriam here could see I do kind of know what I'm talking about sometimes, and that everybody could have something to chew on over Thanksgiving.
No, this was great. I actually like I'm a person that has to know the whole idea to the whole see the big picture before going into details. And this was a great representation to understand why we need to use tuple list dictionary all in one in simple coding here. Uh, Thank you so much for creating this and showing us. It was really useful to understand.
You're welcome. You're welcome. And like I said, you can copy the repo, play with it, add more features to it, turn it into an airplane
Yeah,
game.
I will. Yeah, this was my last next question. How can we get the code? Because I really want to study in detail and understand the
Okay,
connections because it's really interconnected with each other, and it's really good to. If I understand this really well, then it will
yeah.
really help me.
If you go into the original post, right under where you asked, let's see, yeah, like right under your question in our thread, you'll see I posted the repo for you, so you can just copy it or bring it down as a zip.
Thank you.
No problem. And if you have any trouble, just reach out. All right.
Yeah, it definitely looks like so one of the things I am enjoying about my VR headset is that a lot of things can be drawn with JavaScript and it uses the basically the same syntax as you would use with the canvas element for drawing with rectangles. Same thing for the P5JS. A lot of the stuff is kind of the same. So it's really funny seeing the shapes, right? And then being like, yeah, I know how to draw that to make that different. I honestly, because it's Python, we could run that through any kind of 3D compiler and just make a basic build and then have a 3D compiler go, boom, now it looks all fancy.
I could do you one better actually, because Python has more libraries. So let's do level up. So as you can see, I've I've added sound, I've added physics, I've
I
added
see the
drag,
drift.
I've added 3 dimensions,
Oh, okay. You started off on the other side. This reminds me of Geometry Wars. Oh, heck yeah. Also, so I
Let me turn that off
I
so I can
built
hear
my
you.
cube in my VR headset, right? And I plugged in a matrices so I could see a shape. And I'm just now learning about matrices and everything. Uh, is that something you use? Like matrices of array, or I think it's called lists in here. I heard you guys mentioning that, but like an array inside an array or a list inside a list.
Yeah,
Uh,
so that would be more of that would be more of a dictionary because you can have a dictionary inside of a dictionary and you can have a list inside of a dictionary.
Okay,
Yeah.
okay,
So like I said, it's going to be the same concepts. It's just different syntax.
right. And I see all the X, Y's. Yeah, dude, I have to build the wireframe. That's what I realized is I actually have to build the wireframe box within to make it put together itself. Because what happened is it took the four shapes and placed them just in front of me, four squares.
Yeah.
I'm like, why ain't this building? And I went through the code and basically did what you did. I went to Copilot and I'm like, why is this not working? Why am I getting this error here? And it boiled down to it's using the world as a reference for the frame because I haven't built a box frame. So it just puts four squares out into the world symmetrically. I'm like, oh, oops.
And I would
Whenever
say probably rather than depending on like JavaScript because it's going to be web browser specific for that, you might look into either what is that one? They have that it's the cube.
Unreal,
No, not Unreal. It's for like tablets and
Unity,
everything. Unity, yeah. So
that's C.
Unity, yeah, Unity is a C language just like this. And so Python and Unity and some of these other C languages that aren't as browser or server dependent as JavaScript might give you
Yeah.
a little bit more flexibility because you're going to have the ability to import libraries like we did at the beginning of this. So rather than having to worry about all of that stuff that you were just describing, because a pygame, all I got to really do is just be like, how do I want my window height? Like because it's going to throw that P5 canvas out there for me basically, and it's
And
going to have it all already self-contained with all its rules and logic.
that's what that's how my AI actually refers to the material because first it's what I'm doing is really meant for three-dimensional rendering in the browser, right? But you have what's called a WebXR socket plug into the browser where I can set a button on the browser and in my VR headset, get on the browser in there, activate the button, and then it renders me in the browser as its three-dimensional world. And yeah,
Yeah, I don't think my
it's
dyslexia would like that very much. Yeah.
it's it's definitely one of them things, dude. I've spent 6 days making a cube, brown ground, and a light source. They all work now. They all work. Get it working, right? That's
Yeah.
all I gotta do. But one of the things that is spoken of is how AI uh not AI, Python can be used a lot more with the heavy load computing where JavaScript's actually heavy for computing, even for browsers. So yeah, I definitely, and that's the thing too, is I was telling Mouse, like, I don't even really need to study Python because I know JavaScript and I've looked at Python enough. It wouldn't take me but a second to figure it out. Uh, so I think C would be my next language to learn, but we'll see how time treats it.
I would argue spend more time on Python because the fundamentals of it are going to really take you into the path that you want to go into. Because I know you're really into AI and machine learning and a lot of these things. So all the back end these days is usually written in Python.
Yeah,
And so JavaScript is great for what it does, but it's very limited to just the web. It does great everything for the web. Like I still write in it, but usually now I write in Python and then I tell my helper to translate it into TypeScript.
I'm learning about TypeScript in React right now as setting params for uh
Yeah.
when I'm making functions, if I want to be fancy, to put it at the top of the file. And then that way, as you go through files and you hover over whatever function I'm using or component, it tells you what the pieces are. Dude, it is super clever. It's a good bit
Yeah.
extra work, but it's that documentation you're talking about that helps.
Yeah. And Python comes with that already installed with the types. Like we were going with Miriam last class, we would pull in if you wanted to know what this was, you would just type of.
Yeah, see, I love that. And the thing is you actually get to define that as the person that's creating that. I also noticed I keep wanting to call it an arrow function. I'm just going to call it an arrow, that sometimes you'll have an arrow pointing off to the side telling what kind of value this is a question. It's telling what kind of value is going to be returned.
Right. As a
Okay.
default. Yeah. Because Python doesn't have arrow functions. It also doesn't have template literals. Recursion works a lot differently. Uh, also, type coercion works a lot differently. So it's not as flexible as JavaScript, which is why you see now that you're using TypeScript because you need that rigidity.
Yeah,
Like you
that's strict
don't.
mode.
Mhm. So this already comes in a strict mode. Python has one mode.
See, I didn't know it was what's the word I'm looking for? Technical like that. Honestly, I personally kind of think Python's gross because I like my curly brackets. My curly brackets, my parentheses, that's how my brain knows that, hey, check out this chunk of code here. When you put indents in and that's how you nest, I I overlooked a good bit in the beginning. It took me a minute to get used to seeing that the indentation is your code block.
Yeah.
Uh, but it,
That's just meant to make it more beginner friendly. So the Python designers originally wanted it to be less overwhelming. Like, because one of the things that everybody struggles with when they first learn JavaScript is which bracket do I use when? Which backtick do I use when? Which, you know, so with Python, a lot of the stuff, like I was telling Miriam, is if you need it, generally you can type it out and it's going to be what you think it is. Like if you need the sum of something, sum
yeah,
length is len. You need a tuple, there's your tuple. You want to draw a line, you
yeah,
know? So it takes a lot of the natural language and helps you translate a little bit easier into machine language. Because ideally, the more you can communicate correctly and accurately with your computer, the more effective as a programmer you will be.
right. It's not like we're writing binary, and that's what we're really talking to is binary.
Right.
But I gotta go pick up some dinner, man. It was fun. I appreciate the lesson.
Yeah, no problem.
You
All
guys
right.
have
Everybody have a good holiday, and I'll see you after the break.
deuces.
Bye, Eric. Thank you for the class. It was amazing.
You're welcome. Reach out anytime.